हेलो दोस्तों, कैसे हो। मेरे इस YouTube चैनल में आपका स्वागत है। तो चलिए शुरू करते हैं। The topic is design of quarter joint. No, what is a quarter joint? No, before we understand this, what is a quarter joint and how to design it, let me tell you that we always use the formula stress equal to load upon area. So this gives me the formula as load equal to area into stress. Same formula I have written in this way. So for example, this is a rod and this rod is subjected to force in this direction and in this direction. Let the magnitude of this force be 30 kilonewton and this is also 30 kilonewton. This cross section is circular. This cross section is circular. This is a pull force. This is also a pull force. So I can say this is tensile force and this is also tensile force. Because of this, what will happen? Stress will be induced in the material. Stress will be induced in the rod. So this is a rod. Before that, consider a case like this is a rod, again a circular rod. Will there be any stress in this rod?
No, sir, force is not applied.
Yes, as there is no force, as there is no force, so there will not be any stress. If I put load equal to 0 here, then here I will come to know that if there is no force acting, then there will not be any stress. Because the left hand side is 0, right hand side should be 0. So we can see here that if there is no force acting, there is no stress. Now consider this case where the pull force or tensile force is acting. Now because of this pull force or tensile force, what will happen? This rod will be stressed and this will be in tension. The rod will be in tension. And if you are asked to find the area of the rod, so how will you find? You will use this formula. Load is equal to 30 into 10 raised to 3. Since it is circular, I can write the area as pi by 4 d square into stress. Now can we find two unknowns from one equation? No. We need to know the value of stress, then only we can find the value of diameter. Now what is the value of stress? From where will we get the value of stress? We will get the value of, yes, from the design data book. And from where the design data book have found the values? They are found from the tensile stress. Tensile strength from UTM. Okay, so from UTM, they have these values of tensile stress and yield stress. So I will put here the value of yield stress, SYT. What is this SYT? This is yield stress. Now all of you know what is yield stress. Okay, it is the stress at which material starts yielding. It is the stress. And ultimate tensile stress is obtained where? It is obtained here. So we are not interested in this. I told you that hey, we are interested in the yield stress, upper yield stress, lower yield stress. Okay. So this value is obtained from the yield stress. Now, if I know this value of yield stress is suppose 220, so I will put the value of yield stress here to 20. Here I will get the diameter of the rod. Is this clear to all of you? This will give me the diameter of the rod. It will give me some value in some mm. So this is clear to all of you. Now tell me, if instead of 30 kilonewton, the load increases to 32. And suppose we have solved this, and we get the value of D. Now I don't have calculator, so what I will do here is I will assume the value of D after solving this comes at as 35 mm. Okay, this is a value which I have obtained after solving. Now this is done. Now say example, instead of 30 kilonewton, the load increases to 32 into 10 raised to 3 equal to pi by 4 d square into SYT. We have designed this. This is what is designed. This is designed, and we got the value of D as 35 mm. But now this is designed for what load? 30 kilonewton. But the load suddenly increases to 32 kilonewton. And what is the value of this? This value is 35. Is this going to change? No. We have already designed the rod, and that is going to be fixed. So this is not going to change. This value has increased means what about this? This will, let us assume that it increases to 240. What does this mean? This means that the induced stress, you understand the meaning of this word now, induced stress. The load applied is this 32 kilonewton. The diameter is fixed, that is 35. Because of this load of 32 kilonewton, this material or this rod, in this rod, the stress which is induced is how much? 240 Newton per mm square. Okay, is this clear to all of you? This induced stress, the stress which is induced or which comes in the material because of the applied load. Here you can see the applied load is how much? The applied load is 32 kilonewton, that is 32 into 10 raised to 3. This diameter is 35, so this is pi by 4 into this pi by 4 into 35 square. That is the area. This remains the same. So what happens here? This SYT increases. This becomes 240. So this is induced stress. And what is the yield stress for this material? Yield stress is 220. So you tell me now, this material can bear a stress of how much? It can bear a stress of, or it can sustain the stress of, yes, 220. Right, 220 Newton per mm square. But if it increases to 240 Newton per mm square, if it increases, then what will happen?
Then the material will not be able to sustain, or it will not
Yes,
be able to
this
applicate.
material will not be able to sustain this 240 न्यूटन, क्योंकि जितना पॉसिबल है 220 पॉसिबल है, बढ़ गया 20, बढ़ गया ऊपर से, बढ़ गया, तो इस मटेरियल विल नॉट बी एबल टू सस्टेन दैट फोर्स, applied force. And if this is in tension, this material will fail in tension. So this is called as failure of material. Okay, this material has failed now. Why this has failed? Because it was designed for a load of, 30 kilonewton, and the load suddenly increased to 32 kilonewton, and it cannot sustain that extra increase in the load, and it failed. मतलब वो स्ट्रेस कितना सस्टेन कर सकता है, उसमें स्ट्रेस, उसका स्ट्रेस का वैल्यू कितना है 220, और स्ट्रेस आ कितना गया उसमें 240, so it will definitely fail. Now if we don't want this situation to happen, then what will we do? Instead of, you can see here, instead of designing it at instead of designing it at 220, what will we do? We will say that is SYT is equal to 220, factor of safety is equal to 2. So I will say that permissible stress equal to 220 divided by 2 is equal to 110. So I will not design at this value of 220. I will not design at this value of 220. See what I will do. I will design it like this. Again I will write the formula, load equal to area into stress. Load is how much? 30 into 10 raised to 3. Area is what? Pi by 4 d square. And stress is what? 110. Now see here. Here earlier it was 220. Now I am taking only 110. So the diameter value that I will obtain will not be 35. Will not be 35. It will be somewhere around 50 or 55. Okay. Any random value. We are not calculating this. It is 50. Now see this scenario again where the load increases. Now the load increases and it becomes 32 into 10 raised to 3 equal to pi by 4 d square into this I call as induced stress now. Induced stress. This 32 into 10 raised to 3 is fixed. This diameter is fixed. Now this will be how much? This will increase. Since the force is increased, this will also increase and this will increase to suppose 190 or maybe 200. Increase to 190 or 200. Then in this case, will the material fail?
No, sir.
Yes, material will not fail because what is the limit that the material can have? It can have a limit of how much? 240. It can have a limit of 240 Newton per mm square. जब तक उसमें जो stress induced हो रहा है, that induced stress is below 240, it will not fail. Now here, even after the load is increased because of any reason, the induced stress increases to from 110 to 190, maybe 200, maybe 220, maybe 240 तक भी जाएगा. Then also it will not fail. Only if it exceeds beyond 240, then only the material will fail. So this is the need of factor of safety, and this is how we design a part. Is this concept clear to all of you? Any doubt to any one of you? No, this diameter is equal to 50 mm. When I say that I have found that the diameter of the shaft is 50 mm, it means that I can write here that I have designed this rod. I have designed this rod. I told you that there are 4 things involved in design: taking decision, actual finding dimension, aesthetic and ergonomics. So here I can say that I have designed this rod. Now with this background of what is induced stress, what is permissible stress, what is factor of safety, what is yield stress, and how do we design a particular part. We will start design of Cotter joint.